Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to be learning how to solve systems of linear equations by substitution. Little side note, this skill is useful for also solving systems of nonlinear equations. So I hope this helps you out both now and in the future. Other than solving systems of linear equations by graphing, there are two other ways to solve systems of linear equations algebraically. One being substitution and the other elimination. Today we're going to focus on the substitution method, so let's get right to it. What is the solution for this system of equations? Well, when we're using the substitution method, the first thing we want to do is look at the given equation and solve for the variable of your choice. I do recommend for you to try to always solve for the easiest variable. So in this particular case, we don't have to solve for anything because they've given us the value for y equals negative 2x plus 10. So we've already solved for the variable of our choice. Next, substitute the expression equal to the variable you just solved for into the other equation. So we're literally going to go ahead and take this negative 2x plus 10, which is the y value, and substitute it into the y of the other equation, which is going to look like this. 3x plus 5 times the y of negative 2x plus 10 equals 8. Always remember to distribute when you're solving. So I have 3x minus 10x plus 50 equals 8. I'm going to combine like terms here and then subtract 50 to both sides. And then remember that I can cancel out multiplication with division. So I divide negative 7 to both sides and x equals 6. So that's step 3. Go ahead and solve for the missing variable. Now step 4, substitute the value for the variable you just solved for into the either equation and solve for the missing variable value. At this point, you can literally go ahead and plug this x equals 6 into either of the original equations that they gave you. I'm always going to choose the easiest task. So in this particular case, I'm going to use the first equation, which was y equals negative 2 times x, which is 6 plus 10. So that's negative 12 plus 10, so y equals negative 2. So my solution in this case is 6, negative 2. Now remember to always check your work. It's always very important to check because we are human and we can make mistakes. So if I were you, I'd go ahead and do a real quick check by plugging in that solution and making sure that it works for both equations. Y, which is negative 2, does that equal negative 2 times 6, which is negative 12 plus 10? Yes. Second equation, 3 times 6 is 18 plus 5 times 2 is negative 10. 18 plus negative 10, does that equal 8? Yes, and that is my solution. Next, let's go ahead and solve the system by substitution. I'm going to go ahead and scan both equations, and I'm going to notice that this y will be the easiest to solve for, and I'm going to start by subtracting 2x to both sides. So we've got negative y equals negative 2x minus 15. I'm going to get rid of that multiplication of a negative 1 by dividing negative 1 to both sides. Remember that that means you want to divide that negative 1 to everything on the opposite side. Y equals 2x plus 15, which I am going to literally substitute into the y of the other equation, which I go ahead and plug in for y. Please remember always to distribute. So that's 6x plus 45 equals 5. I'm going to add the like terms and I'm going to subtract 45 to both sides, giving me 10x equals negative 40. I'm going to cancel out multiplication with division, and x equals negative 4. Now that I know that x equals negative 4, I'm going to go ahead and plug that value into the easiest of equations, which is the one that I solved for y. So y equals 2 times negative 4 plus 15. So y is going to equal 7. Now let's go ahead and always remember to go ahead and check. So my solution, I say, is negative 4, 7. Let's go ahead and plug it in and check. That's going to make life a lot easier for us in the long run. So let's go ahead and check it. 2 times negative 4 is negative 8 minus 7 does equal negative 15. And 4 times negative 4 is negative 16 plus 3 times 7 is 21. That does equal 5. So we are good. 4, 7 is my solution. Next, let's solve the system by substitution. In this case, hopefully you notice as well, this x is going to be the easiest to solve for, so I'm going to go ahead and add 3y to both sides. X equals 3y plus 5, which I'm going to go ahead and substitute into the x of the other equation. So I've got negative 2 times x, which is 3y plus 5, plus 6y equals 3. Always remember to distribute. Negative 6y minus 10 plus 6y equals 3. And look at what happens here. Sometimes your variables will cancel out. If you are left with a false statement, like this one here, negative 10 does not equal 3, that means that these are parallel lines. That means that it's an inconsistent system and there is no solution. Since they are parallel lines, the slopes are equal and the y-intercepts are different. All right. Next, let's go ahead and solve by substitution. I'm going to go ahead and realize that this y is the easiest to solve for. So I'm going to add 3x to both sides. Y equals 3x plus 2. I'm going to go ahead and take that y value of 3x plus 2 and literally plug it into the y of the other equation, giving me 6x minus 2 times y, which is 3x plus 2, equals negative 4. When I distribute, I once again notice in this example that the variables will cancel, but in this case, this is a true statement. So when the variables cancel and you have a true statement, you have what's called a consistent dependent system. That means that it's the same exact line. So that means you have all real numbers as your solution, or you can say infinitely many solutions. And it is the same line, so the slopes and y-intercepts are equal. All right, so that's done for our mechanics. Now let's work on some applications. Let's look at a word problem. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, softwares, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? Now, my biggest suggestion is always to not only read the word problem a couple times if you have to, but always immediately identify what you're solving for and label. So I noticed here that they're asking for the cost of each lesson, which I'm going to go ahead and call Y. The cost of each lesson. And they're also looking for the one-time fee for materials. So I'm going to call that X, the one-time fee. And when you pay for this, you're paying an amount, you're going to pay something, a total of something. So we're going to call that P. And we'll call this P, total paid. Now this advertisement's giving you two different options. They're telling you that you could pay a total of $300 for 6 lessons, Y, plus the one-time fee of X. Or you can go ahead and pay $480 for 12 lessons, Y, plus the same one-time fee, X. Let's go ahead and use substitution here to solve. In my opinion, I'm going to go ahead and solve for this X right here. So I'm going to subtract 6Y to both sides, giving me X equals 300 minus 6Y. I'm going to take that value of X and literally plug it in to the X of the other equation, giving me 480 equals 12Y plus X, which is 300 minus 6Y. I'm going to add like terms of 12Y and negative 6Y. I'm going to subtract 300 to both sides. 180 equals 6Y. Divide both sides by 6, and Y equals 30. So that means that our Y, our cost per lesson, is $30. Now that we have Y, let's go ahead and plug it into this equation here that we set up, this X equals equation. And therefore, X is going to equal 300 minus 6 times Y, which is 30. So X will equal 300 minus 180, which is $120, which is my one-time fee. And now we know the cost per lesson and the one-time fee, the power of substitution. Last but not least, go ahead and take out your trusty calculator for this one because it's an easy question. Don't let the words or the decimals frighten you, but let's go ahead and make life easy and use our tool of a calculator. The participation rate in the workforce is defined by economists to be the number of individuals employed divided by the number of individuals 16 years of age or older. The participation rate for men is P equals negative 0.08 plus 243.96, where T is the year. The participation rate for women is given by P equals 0.24 T minus 415.10, where T is the year. Based on these models, when, if ever, can we expect the participation rate of women, blue, in the workforce to equal the participation rate of men, which is in green? When are they going to be equal? Well, let's use substitution. They want to know when is the participation rate of men going to equal the participation rate of women. Well, let's go ahead and take the participation rate of men and substitute that in, which is negative 0.08 T plus 243.96. And then let's take the participation rate of women and plug it in. So that's 0.24 T minus 415.10. So now we're going to solve for T. So I'm going to go ahead and add 415.10 to both sides. And add 0.08 T to both sides. And that's going to give me 659.06, and that is equal to 0.32t divided by 0.32 to cancel multiplication, and that is going to give me t equals 2059.56, and we are looking for a year. So in the year 2060, approximately, there will be the same participation rate for both women and men in the workforce. Thank you very much. Hope you learned a lot. Have a great day. Come back anytime. Take care now. Bye-bye.